Hello, everyone. Welcome. We are so excited to be starting this brand new streaming series. So it's Timescale Live. And these series are going to be happening once a month. And for this month, we have been focusing on kind of crypto, Web3, and just decentralized data in general. So of course, for our very first Timescale Live, we wanted to bring on someone who is very knowledgeable in the decentralized market space. So we're really excited today to have our guest speaker, Mikko Ohtamaa, who is the CEO of Trading Strategies. So thank you so much for coming on to our stream today.
Yeah, hey, thank you so much, Miranda. Thank you. Pleasure to be here. And you need to have a guinea pig in everything. So maybe that's my role.
Yeah, and we were just even talking about how I was admiring Mikko's board game collection behind him, because I just was seeing that and was like, oh, that's awesome. So not only is he very knowledgeable in decentralized markets, but also a avid board gamer. So which I love board games as well. So always fun things to learn. Yeah, and Mikko, if you want to just go ahead and start up with your presentation, yeah, we can just get rolling with everything.
All right. Give me a second.
Oh yeah, take your time. While Mikko is doing that, if you are newer to Timescale, we have a Slack and forum where you can always ask more questions. And at the end, we are going to be answering questions that you might have for Mikko during his talk. So please ask any questions that you have in the chats, whether it's YouTube or wherever you're watching right now. And we will get to them later on. So
you are guys still seeing me?
Yes. Awesome.
All right. So here we go. And again, thank you for everybody. As Miranda said, I'm a co-founder of a company called TradingStrategy.ai, which is also our domain name. And as a Timescale Live, we are really a new company, so we haven't been around for many months, and are really new to this even newer decentralized finance business. And basically, what we are doing is that we are providing algorithm traders, or algo traders, as we call them, an opportunity to trade on decentralized exchanges and blockchain markets. And these markets are a little bit different from the exchanges or online brokers you might have used in your own life. For example, buy stock, or if you go to a exchange like Coinbase where you buy Bitcoin, it's a little bit different experience. And yeah, please follow us on Twitter, and let's get going.
Oh, also, it looks like that we can't see your slides for some reason. It says loading.
Yeah, okay, I know this because
Okay.
it has happened before, because if I switch to a full screen, I think it disappears or something breaks. So let me see if I can
technology.
just make yeah. If I can just make this, I think this is good enough. Are you guys seeing me now?
All right, let's see. Looks like still not seeing it, is what we're hearing.
Okay, let me do it again. Yeah, let me do this. How about now?
It looks like we okay. We saw a screen. Okay, there we go.
Awesome. All right, so I'll keep it in not full screen so it doesn't disconnect it.
Awesome, sounds good.
All right. So first few items on the background on decentralized finance. So probably everybody is familiar with the blockchains and bitcoins as a concept. There are plenty of cryptocurrencies out there, but most of them are being used for speculation, and that has given some bad rap for the reputation of the cryptos. But blockchains can be used for a lot of other things as well. They can be used for creating services that run purely on a blockchain. That's called so-called on-chain interactions. And in that case, your whole business or service is only a smart contract that's deployed on a blockchain. And after deployment, it's going to be there forever. It's fully transparent. Everybody knows what's going on in there, and it's never going to go down, and you never need to pay for the servers again. And this also means that there are no admins. There's no risk with the SaaS company or the service provider, so to say, what has happened, for example, many times with the Google products, that they are just discontinued and then it disappears. So this is not going to happen with the decentralized finance. And what it makes also interesting is, especially from the business point of view, that it has 3 interesting elements for developers. One is open source. So if you know that how back in the day, Linux first, it took the market from a Unix operating systems, and then later Linux took also the markets in the form of Android or from the mobile operating systems. You know that the open source is killing it because it's just much better for developers and the integrators to use open source than the proprietary services. Other one is open data, because the data is replicated to all the blockchain nodes. You can access it easily and so on. And you don't need API keys, and everybody can connect and read it. But I think the most interesting innovation is the open ledger, which means that when you connect to a blockchain with your private keys, you can make a transactions there yourself. And again, there's no API key, there's no acceptance process, but you can just like create a wallet, get some money there, and get going. And alone open source would be a very powerful concept. For example, think an idea as a developer that your bank would be on open source. So how great would be that? But if you combine it with open data and the open ledger as well, it means that you can really nail down the cost efficiency when it comes to software development. And it means also that the services that run on a blockchain, especially decentralized finance services like lending and trading exchanges, they are super efficient for the consumer, which in turn means that it should be very attractive value promise. And this I covered, so let's move forward. And maybe a little bit more on the nature of the decentralized finance for developers, because everybody's operating in the same ledger in a blockchain. Everything is pretty much open source. It makes very easy to mix and match different services and different service providers and so on. So you can create your own service that is built on the top of somebody else's service. And because the base layer you are using is open source and is very transparent and easy to use, it means that you can stack up these so-called money Legos very efficiently. And then we also have the same normal software development issues, that when everything is open source, it is super easy to test. You can spin up your own test environments. You don't need to use sandboxes or any kind of limited API access for testing that some of the SaaS providers are giving to you. Whoops. Hello, let's try to move forward. And blockchain is basically it's a one giant distributed database, where everybody's using a public private key cryptographic to sign the transactions. And the state of the database, it's actually distributed to all of the nodes. And it means that the nodes can be pretty much everywhere in the world. And this is going to create issues that you are already seeing with the data centers, but in the blockchain, it's even more visible, because there are so many nodes and they are everywhere. You are really not controlling the routing, how the information propagates. You are going to hit the light speed issues. So, for example, if I have my own node here in Europe and there's somebody else in Australia, and those nodes try to agree on the state, it means that there's going to be some delay. And with this delay comes the issue of consensus. The nodes can't always agree what is the latest state, and but what they usually can agree is that what is the state in the past. So it's basically stacking up blocks. Block is the minimum unit of the state, and you can't know what's the latest block because you can't define where in the world it happens to be, but you can easily agree what were the blocks in the, let's say, 100 minutes ago. And this creates a kind of a unique challenge for the application development, because it means that in a normal APIs, you do a post and it changes the state and you get the results back. But in this case, it means that if something has happened in your own worldview, but it hasn't happened for anybody else yet, it means that the timeline of the events may change. And this means that you actually need to go backwards in time when you are reading data, because suddenly you find out that the block or the state you have was not actually the right one, and you need to go back some blocks and then hop to the right tip of the chain, as we can call it. So you hop to the right fork and keep following the state there. And this, of course, means that you can't have a single timeline in the database. You either need to delete the data, or you need to maintain a multiple forks of the latest state at the same time in the memory. And also, because the chain is public and everybody can access it, it means that there's a lot of malicious actors coming there. They try to spam you, like in old-fashioned email spam, sending messages and polluting text fields. They can try to do investment scams. They can try to attract you to buy something which is not real, or they can just try to do a price manipulation and so on. And if we go to because the cost is so cheap and it's so easy to come in and there's no accountability, it means that a lot of data out there is garbage. It's useless. It's just like either somebody was doing testing, they just, for the sake of testing, they created 10,000 trading pairs that don't really mean anything, but you still need to index this data and try to figure out that, like, is this real or should I filter it away somehow? And for us, as we are a market data service for traders, we are using TimescaleDB for the process where it shines. So basically, it's indexing time series data. So it's indexing price data. It's indexing liquidity data. It's indexing trades, whatever is going on those decentralized markets which we are supporting. And as I said, there's a lot of data. So the main benefit for us is that the TimescaleDB scales. We are actually running on a single server. I think there's a few terabytes of data now, and for us, there's no need to create a complex clusters or sharding yet. It's just like works fine with the single server, and we hope to keep it that way and try to scale vertically instead of creating clusters. The other benefit we have with TimescaleDB is that it's very advanced automated features like continuous aggregate views allows us to process the data we are ingesting into TimescaleDB in the TimescaleDB itself, and we are using this to, for example, create a so-called a price candle time series data, which I'm going to show you later, and basically we get this feature from the TimescaleDB for free, and it means that we can save in development time because we don't need to maintain a complex logic to do it ourselves. We just use whatever TimescaleDB gives us from the box, and it's like half done. So it's basically giving us features for free. And as I said earlier, the blockchains, the tip of the chain, it tends to be unstable, which means that we need to backtrack now and then. And it means that when we are using hypertables, we can easily drop few of the latest items and instead actually replacing data there, which is the correct data we accurate later. And what I love in TimescaleDB most is its active developer community and high quality documentation, because if you go to a Stack Overflow and you try to ask help, you usually you get help, and you can find examples in documentation. Sometimes it's just like a matter of not understanding where to look or how to format your question. Let me see if I can share. And now I'm showing our live website. So here you can see that we have 3 blockchains, 2,000 exchanges, and 800,000 trading pairs here, and some most profitable trading pairs today here. And let's click one open here. Let's click Helena BNB. This is Helena financial trading pair on PancakeSwap exchange on a Binance Smart Chain. I have never seen this before, so you can see that it's quite new. It started 13 days ago. And all of the data here is coming from TimescaleDB. Some of the labeling data here, for that we are using the Postgres part, so it's just like a normal SQL with relationship. But most of the time series data, as you can see here, this is coming straight from the TimescaleDB over our own open API. And here you can actually see the continuous aggregation views in action. So if you choose between the time frame resolution, it switches like what aggregation view it is following, and all of this like from 1 day to 5-minute data points is done in the TimescaleDB, and we didn't really write any line of code for this. And what else there could be? Yeah, I think, yeah. And here we are also like one thing is this is a price data, so everyone is familiar with how the price moves. But other one we are doing it that's kind of specialized for a decentralized market is so liquidity. So how deep are the trading pairs? How much money there is in the market? And you can't get this kind of liquidity analysis on a normal let's say stock market data services, because the concept just doesn't exist on the stock markets. So we created one ourselves, and again we are using the same TimescaleDB continuous aggregation view logic, and this time instead of doing price, we are displaying how the liquidity of the trading pair changes over time. And here you can actually see that here are individual samples. Okay, here you can see that somebody added liquidity to the market there. it was worth of the $2,800, and here is a bigger one. So somebody added $11,000, and again here we can see that somebody went there and added 9,500 USD. Okay, so this is my overview how we are using TimescaleDB. I hope there was something there you learned from DeFi, TimescaleDB, or markets, or what we do. And we are also hiring. So if you know finance software, the software developers in finance that are using Python and who likes to trade, you can join us, because we are now hiring analysts. And yeah, please follow us on the Twitter and the Telegram and the newsletter, and hope to see you soon in the TimescaleDB community Slack. Thank you.
Yeah, that was awesome. Thank you so much, Mikko, for that talk. Yeah, I loved the analogy that you used for describing like how technologies can build on one another within decentralized like data as money Legos. I thought that was really fun. I liked that analogy. Yeah, that was great. And it was awesome to see your website too. Yeah.
All right. Thank you so much.
Yeah, thank you. And we just a reminder to everyone who's watching, we will have a Q&A session after this next talk. So definitely ask your questions, and then we'll have Mikko and then our next speaker, Attila, come back to answer any questions. So yeah, thank you again, and we'll see you in a bit.
Thank you.
Thank you. And we now welcome Attila. Hello,
Hi.
our very own. Yeah,
Hi,
how's
are
it
you?
going? I am good. It's been a great day so far. I mean, we have had an awesome talk. We're gonna have a great demo, from what I hear, right?
Yeah,
Is
I
that
mean, you know, for those who don't know, we actually just came back from Bitcoin Miami, and I just wanted to say that it was really good to meet that community in person and see how see what those people are building, and yeah, I'm just really excited that we are trying to create something interesting and useful for the crypto community. So yeah, I'm excited to talk about it and demo something that hopefully the community will find interesting.
Yeah. Well, and it's so cool. Like I really appreciate Mikko coming on and even showing like how they use TimescaleDB. I don't know, as you know, we're both from Timescale. It's just like so fun to see the applications and like how people get use out of our products like continuous aggregates and this cool functionality. So, and I'm excited for this like next demo thing that you're going to do. Plus, I love the t-shirt. I know that 𝗏𝗲𝗃 in the chat threw that was right, the t-shirt for the Bitcoin conference, right?
Right.
Yeah, just the Eon holding the coins is just amazing.
Yeah. We're gonna need to create a lot of these t-shirts because they were really popular, but we only had a few of them, unfortunately. But they were really popular.
Yeah, we'll just have to make a comeback. All right, I will let you go ahead and take the stage
Great.
and teach us about continuous aggregates and finance, crypto.
Great, thank you. So I'm sharing my screen. I hope people are able to see it. I'm going to do a demo, as Miranda said, but before that, I just wanted to quickly sort of set the stage and also follow Mikko's great presentation. The focus of my presentation will be about storing and analyzing crypto data, specifically market data in TimescaleDB. And I want to demonstrate how current TimescaleDB users are using TimescaleDB to power their crypto and financial data applications. Similarly, how trading strategy does it with TimescaleDB. But before I start, just real quick for those who are not so familiar with TimescaleDB, we are an open source time series database powered by Postgres. And we are a PostgreSQL extension, actually. So we extend Postgres to be able to scale your time series data. And we also make it easy for you to work with time series data within this, the huge PostgreSQL ecosystem. And why would you use TimescaleDB for crypto projects? Also, why current users are utilizing TimescaleDB for their data-intensive applications. On a high level, we usually mention these three things that specify why TimescaleDB can be a good choice for you. So first of all, we have reliability, which comes from the fact that TimescaleDB is Postgres. We are not just pretending to be Postgres. We are really Postgres, and we inherit all the benefits of Postgres. Then scalability. TimescaleDB is if you use TimescaleDB, usually you create hypertables for your time series data, and those hypertables are actually powered by our internal partitioning feature to make your time series data more scalable within Postgres. But you can still join and do other Postgres things with your time series data. And finally, maintainability. We have a lot of functions and features within TimescaleDB that makes it easy for users to maintain the huge data sets over time, including all kind of automation processes and other superpowers, which are actually really, really interesting when it comes to specifically crypto projects and data-intensive financial projects, because we have quite a few superpowers which helps you store and manage your data. Now, obviously, I only have 20 minutes, so we don't have time to discover all of these now, but I will highlight one of these features, which actually Mikko mentioned as well, which is continuous aggregates, because continuous aggregates is one of our, I think, flagship features that are really helping users scale up their data and use Postgres to power data-intensive applications. So let's dive a little bit deeper in continuous aggregates, why they are useful, and then I will demo it using real-time crypto data. Continuous aggregates is basically materialized views for time series data. What this means is that they work very similarly to materialized views, but under the hood, we provide a more efficient way to refresh those materialized views. And we also provide a way for you to access not just the materialized portion of your aggregated data, but also real-time data, which is very important if you're building a site or an application similar to trading strategy, where you can see real-time or close to real-time data on the website. So quickly, some of the benefits if you want to use continuous aggregates for crypto market data. So one huge benefit is the increased query performance for time-based aggregations. We provide a time bucket function, which you can use with continuous aggregates, and then you can create arbitrary sized time buckets to aggregate your crypto data within a continuous aggregate. And because of the materialization and the aggregation, what you will see is that your queries will be faster with continuous aggregates. Now, when it comes to trading and analyzing crypto prices, one of the formats which are used by trading strategy and a lot of other people and companies is the open high low close volume or candlestick format. And TimescaleDB is actually really good at creating this format and then storing this storing the data points, the candlestick data points. So later you can quickly query the data within your application. And with contains aggregates, we make it quick and easy for you to query not just real-time data, but also historical data. And as I mentioned, the materialized portion will be really useful for historical queries when you're trying to get data from the past. And disk data will come from the disk, so it will be really fast. But on the same time, if you're creating aggregations as visualizations for real-time data, maybe you are creating 1 minute buckets or 1 minute candlesticks or 5-minute candlesticks. You also need to access the not just the materialized portion, but the underlying row data or tick data. And you can use context aggregates to access this type of data on the fly. And the performance should be really good as well, because you're only reaching back 1 minute or 2 minutes or 5 minutes in the past. So the amount of data should be easily manageable. And then we provide automation, so you can delete or compress older data on schedule from context aggregates to save disk space. And as I mentioned, you can do all kinds of PostgreSQL things that you can do otherwise. You can join your data once you have created the context aggregate. You can also use window functions on candlestick data, and I will demo these two things as well in a second. And then with context aggregates, what you also get is a petabyte scale storage or a petabyte scale database. I would mention two things related to this. First of all, context aggregates is supported in a multi-node environment, but also under the hood, context aggregates are actually powered by hypertables. And so these two things make sure that you can store a lot of aggregated data in context aggregates. All right, and this is just an illustration how context aggregates work. On the bottom, you have the raw data, and when it comes to crypto prices and market data, it's usually tick data, which can be, which are pricing data, and usually multiple data points per second or per minute. And then in the context aggregates, in this example, we create a context aggregate called 1 hour candle, which can store maybe 1 hour candlestick data points. And instead of querying the raw data, when you query the context aggregate, you query the candlestick data values, so you have much less records to query from, and also the data will come from a materialized form, so your query performance will be much better. And what users usually see on the front end is something like this, as Mikko showed you as well. Candlestick charts can be powered by continuous aggregates. And this is another example from the trading strategy website. And the cool thing is that TimescaleDB can power not just the candlestick chart, the time series chart, but also all the other supporting relational information about trading pairs and crypto assets and exchanges and everything else that you want to store in TimescaleDB. All right, so now I'm going to jump to the demonstration part. So I have a dbver here, which I will use to access a demo database where we are ingesting real-time crypto tick data about different cryptocurrencies. So let me just quickly run this query to get the most fresh data. So as you can see, this is in my time zone. So it's 6:30 where I'm at right now. And as you can see, we are getting data very close to real time about different cryptocurrencies. We have Sol, Dodge, BTC, and a lot of other trading pairs. And for each of these records, because this is tick data, we only have two data points, price, and then the volume data point. If we want to see how many records we have for each symbol, I can just quickly run this query to select the symbol and the number of records for each symbol. And as you can see, we have the most amount of data for Sol, but we also have a lot of data for Dodge, BTC, and other assets. And let's say we want to focus on just Bitcoin prices. We can run a simple query to filter BTC USD trading pair. If I run this, what you can see here is that we have a lot of tick data, very recent tick data. And basically, usually what people do, like Mikko with trading strategy. Also, we have other customers like or users like 𝗥𝗲𝗃. They are aggregating the tick data into time buckets, and so for that we provide hyperfunctions that make it easy for you to create those aggregations. So you don't need to come up with some custom SQL function. We provide those functions for you, which are actually called hyperfunctions. So for example, in this query, if you want to create candlestick data points from raw tick data that we have by default, because that's what we are ingesting, you can use first of all the time bucket function, which will handle the aggregation based on time. In this example, I will create 1 day time buckets. And then obviously we have the symbol, so we are grouping by the different trading pairs. And then here, we use other aggregate functions, like, for example, the first, which is a TimescaleDB hyperfunction, which will basically give you the first data point ordered by another column. So, for example, here, I'm interested in the first price data point ordered by time, which will basically give us the opening price in the given time bucket for the given symbol, in this case, BTC USD. And then to calculate the highest and the lowest prices, we use regular PostgreSQL functions like max and min. And finally, to calculate the closing price and the volume, we use the last hyperfunction, which is very similar to first, but it selects the last value ordered by time, which we need for the closing price. And for volume, the reason we use last, because the data source where we get data, we actually get the aggregated volume from our data source, and so we need to use the last function to get the proper volume for the day. But if you are getting data from some other source, there are chances that you get the volume field differently. So you might need to use some other function like sum or maybe count, depending on your data source. And then I have an extra field here, which might be interesting for some of you, which basically calculates the price difference between the opening and the closing price within the day, and returns the percentage value for each day. And then we are filtering for BTC. So this will create, if I run this, this will create the candlestick values for each day for the past days. And as you can see, for each record, we have the bucket, which is each record is 1 day. We have the symbol, which is BTC, and then the opening price, highest price, lowest price, close price, volume, and the percentage change. And then basically using using these data points and using this query, you can create all kinds of visualizations, candlestick charts, and other time series charts. Now, going further, what users usually do is that they need to run this query fairly often, and not just for BTC, but also for other symbols. So you want this to be fairly quick and easy to query. So instead of just writing this query every time you want to get access to this data, it's suggested to use continuous aggregates to materialize the result of this query. And then as time goes on, you continuously keep adding new and new aggregated records to the continuous aggregate. So it will be very easy and quick to query the candlestick values later on. So if you want to do that, this is how you can do that. As I mentioned, continuous aggregates are very similar to materialized views. So you just need to use create materialized view, the name of the continuous aggregate. In this case, it's called demo one day candle because it's going to store 1 day candlestick values. And then in the select query, we will use the same query that I showed before, but to keep things simple, I will just include the open, high, low, and close values. And so if I run this, this will run maybe for 10 seconds, because in the background, this is actually materializing data right now, and it's finished. And so right now we have a continuous aggregate created. The data is materialized up to up to now. So whatever data we have is materialized and aggregated in the continuous aggregate. But in the future, if we want to keep this continuous aggregate updated, we need to introduce a continuous aggregate policy, which, for example, will refresh the materialized view or the continuous aggregate every day. And so if you want to add a policy like that, you can use this query. This will run every day, and this will refresh a time window between 3 days ago and 1 day ago. And so basically, you want to define a time window where you expect data to be changed. And because we are refreshing the continuous aggregate every single day, we only need to look at data from the past couple of days. And so once it's set up, it's very easy to query the candlestick data. For example, querying a continuous aggregate is the same way as if you were to query a regular Postgres table. And you can define a symbol like BTC USD, and then what you see as a result is the candlestick format. And again, you can use this data. You can use these data points to create visualizations, charts, and just generally fuel your application. Now, I have 2 more things that I want to show you, which are really useful, and that's why it's really great that you can do these kind of calculations within Postgres, because next we can use window functions on top of continuous aggregates. And this could be interesting because if we go back, I showed you one query where we calculate the price difference. And it basically gives you the difference between the closing price and the opening price in a day, intraday in this example. But some people might want to compare not the opening and the closing price, but compare today's closing price with yesterday's closing price. So basically, you're just comparing the closing prices and see how the price change. Now, in order to do that, you can use window functions, and you can use window functions on an already created continuous aggregate. And this is exactly what this query does. We are using the leg window function, and we are comparing the close data field. And in the specific query, what you can also do is that you can compare you can compare the two crypto assets. So for example, you can compare BTC with Ether, and we can use data from the past 2 weeks. So if I run this, again, this is fairly quick because everything is coming from the contents aggregate. And basically what we see here is that we have values for both BTC and Ether, and we are comparing the closing prices. The reason we don't have values for the first two records, because the window function is actually looking at the previous record, and we don't have a record before this value because we are only looking at the past 14 days. But we see how the price changed, and an interesting visualization which you can find on Trading Strategies website is you can see how the price is changed in terms of percentage values, and it's a really good way to compare two crypto assets like BTC or Ether or any other crypto assets. And then finally, the last thing I want to show is how easy it can be to join your time series data with regular relational data. And so in this next query, what I do is we are using the contents aggregate, which we created, which has the candlestick aggregations, and we are querying values from that contents aggregate, including the bucket, the opening price, highest price, lowest price, and the close price. But instead of the trading pair, we are getting this value or data field called name, which is actually the name of the trading pair, in this case, Bitcoin USD. And it's coming from a table called crypto assets, which is just a regular Postgres table. And we are joining on the symbol, which is BTC USD. And so this is just an example, but this really shows you how easy it is to just join any kind of relational data with your time series data. So later on, you can when you build your application, you can display not just time series data and time series analysis, but you can include all kinds of other relational data, which can be really interesting. So basically, that's all I wanted to show. If you're interested in trying this yourself, we have a tutorial that shows you how you can ingest stick data and then create the candlestick values in TimescaleDB, how you can use contents aggregates to do that. We also, in this tutorial, we also give you some tips how you can manage your data long-term, how you can use data retention policies, compression policies on the hyper table or on the contents aggregate. So basically, we give you all the tools that you need to be able to ingest crypto market data and then store it and query it efficiently. And so that's all I wanted to show. I hope it was interesting, and let me know if you guys have questions.
Yeah, this was great. Thank you so much, Attila. It's always I commend you on doing live coding. It's so helpful to see people like code live or query live, really, but in this case. But yeah, I appreciated that. That was great. Thank you. All right, and now we have time for questions. So anyone who is in the chat or watching, please feel free to ask any questions that you want, and you can specify who you would like to ask the question to. I'll go ahead and start off with some questions. So this one is for Mikko first. What advice do you have for developers looking to build on decentralized markets? And what do you wish you knew before kind of getting into that space?
I think like I'm the wrong person to answer this question, because I did exist before the space, and I was actually early enough to be part of the builder, so to say. So I have been growing up for it. But yeah, basically for developers, the skill set what is needed is usually or what stack is used by companies is TypeScript, Python, and Solidity. And my advice is that you probably need to have some years of experience in some other professional programming career, like a web development or something else, before you try in decentralized finance. It's a little bit more challenging, and it's harder to get in. But yeah, but in the end, it's just like any other programming. So you basically go to websites and start reading tutorials and start trying out stuff on yourself. It's so new that there are no courses, or there are only very few courses. Maybe I can drop you guys links later. But it's just like you need to try and see what breaks and learn from the experience.
Yeah, that's a great way of putting it. I feel like I always learn the most whenever I fail or like mess something up or break something, and then kind of learning from that mistake. So that's awesome. Thank you so much, Mikko. So this next question, because I'm still waiting for all of you viewers to ask any questions. So you should still ask questions, please. Especially if you have them, because we love your questions, and we always want you to feel free to ask them. So this next question I'll throw to Attila. What has been your favorite topic that you've learned about within like the decentralized Web3 crypto space?
Okay, that's a good question. I think what really so first of all, I'm really interested in data, and in the crypto space and the decentralized space, there are just so much data. Obviously, when it comes to crypto markets, there's a lot of data. But if we talk about like other aspects of crypto and decentralization, NFTs, there are a lot of data in the NFT space as well. And I'm just really interested in how you can get access to this kind of data, and then how you can use the data to then build something interesting or useful. So I'm generally interested in these things, and I'm really happy to see that Timescale is moving into this direction to provide education for developers who are trying to build data products on top of crypto data. But I'm also interested to see how other companies are trying to build analytical products on top of this space. And yeah, one thing which I mentioned on the during the conference as well, and during Bitcoin Miami, is that the community is just really helpful, and there are some really awesome companies like Trading Strategy and other companies who are building great things. So yeah, I'm just sorry, I forgot what was the question, but I'm just really
no.
excited to be part of this.
You answered it great, Attila. That was awesome. Thank you for your thoughts. And we actually have a question from a viewer. Woo! So this next question, I'm going to pose it to Mikko, because you decided to go with Timescale. So what's your thoughts on why we should consider, or this individual should consider, TimescaleDB over MongoDB or another type of database for candlestick data?
Yeah, I have a limited experience with MongoDB. I have using it in the past. MongoDB is a document database. It's made from web-like data, like pages and stuff like that. So my gut feeling is that why would you use it for candle data in the first place? I feel TimescaleDB is made from time series data, so it's like a right tool for the job. So it's much more efficient what it's doing. It's you are going to need to have less lines of code. It's going to be with TimescaleDB, it's going to be a downhill paddle instead of uphill paddle.
Mm.
Yeah.
Awesome.
Maybe if I can just add one thing, one consistent message that we got from people who are in the crypto space is that like some people who have tried MongoDB, they later on had issues with joining their data easily with other sort of more static data or relational data, and if it takes a lot of time for developers to query data from a NoSQL database and then join it with other parts of the business, at the end of the day, it might be just easier to store everything in a relational database that works well with time series data, because it will be just literally a join to bring your time series data with other kind of data together. So
yeah, that's awesome. Thank you both for that great answer. Both great answers. So we have another question for Mikko. How do you evaluate which Dexes and DeFi services to choose and collect data from, and that you support on your platform?
Yeah. Maybe I can show something on my screen. I'm not sure if my screen sharing is there on the. Hope you see my browser.
Yes, we do.
Yes. Yeah. So we don't really choose. We collect data from all of them, and then we filter it out before we make more candles and so on. So we don't run continuous aggregation for all the data, because that would be just too big even for the TimescaleDB, and we don't either handpick them. So it's all automated, and it's based on the numbers. So what we are going to filter out. And if you go to our documentation, there's a page that says tracked trading pairs and tokens. So it basically explains our process, like what there needs to be on trading pair before we generate candles for it. And basically, it needs to have some trading activity that looks like legit. So it needs to have a certain amount of trades. It's metadata like a token name must look real and so on. So it's basically just like some if conditions before we let in. And one important thing is that it needs to trade. The trading pair always has two tokens, like it's called base token, what you are buying, and a quote token that you are using as a currency. And we only support some of the most well-known quote tokens like USDC, ETH, BNB. And if you have some funny trading pair that says cars and cats, we exclude them because they are not usually very interesting.
Yeah, awesome. Thank you. Yeah, that was great. And cool to learn how you all are kind of parsing through that data and collecting it. Yeah, are there any other questions from any of the viewers today? Going once, going twice. Awesome. Okay, I think that wraps it up for the questions. Thank you. Oh, there was one comment, but it's a funny one. Haha, so no ape or Doge coins or
Yeah. I mean, it's actually a valid point. So some projects are doing that, but when you choose like something that's rare and you are trading with something that's even more rarer, there's no liquidity. So you have both sides of the trading pool are super small, which means that when you do a trade, there's not enough liquidity, and you get what's called price impact. So you are getting like minus, if you do a small trade, it's minus 5% for yourself and everybody else. So it's hurting, and that's why people try to avoid those kind of pairs.
Oh, cool. Yeah, awesome. Thank you. All right. I think that wraps it up. This was a wonderful first Timescale live show, and we a lot of that is because of Mikko. And thank you so much for coming onto the show and doing an awesome presentation. And of course, Attila as well for the demo and also some background on timescale functionality. Yeah, this was really, really awesome. And thank you, viewers, for tuning in, and hopefully you now learned something new or are just more excited about kind of getting involved in the decentralized market space. I know that, yeah, it's always super fun to learn about all of this. So thank you. And then, yeah, I think that wraps it up, folks.
Thanks for hosting.
Oh, yeah, of course. I have the
Thank
easy
you so
job.
much.
Yeah, thank you so much, everyone. And we will see you next month.
Yeah.
Bye-bye.